the quantity of rods. 1, 2, 0, 0, 0, 0, 0 is the quantity of rods. And whenever you're writing things like that, it's easy to make a mistake. Too many digits, it's too much writing in general. To turn a number into scientific notation, first insert a decimal number somewhere within this mess to create a number that is greater than 1, greater than or equal to actually, but less than 10. Greater than 1, but less than or equal to 10. So I would insert a decimal between the 1 and the 2. Okay? Right about there. And I'm kind of zooming in on it right here. Now clearly 1 and 2/10 is not the same as 120 million. However, if I multiply 1 and 2/10 by 10 to the power of however many spaces away from here it is, I have mimicked this number using scientific notation. So 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. So this decimal is 8 spaces away from where it really lives in the star, where the star is. Okay? To test to see if you're right, rewrite your number 1, 2, start where you put the decimal, and go 8 positions to the right, filling in with placeholder zeros where necessary. I'll show you what I mean by that. 1, 2, 3, 4, 5, 6, 7, 8, decimal. Where every hoove or little thing is, place zeros. Commas where necessary. Boom, boom. Is this number the same as that number? Then that means 1.2 times 10 to the 8th indeed does equal that. It's easier to show you than it is to explain, but I'm going to finish the explanation. So after you've inserted your decimal to create that number that's between 1 and 10, you multiply that decimal, so here's the multiplication, by 10 to whatever power, n being just an indicator, where n is how many spaces away the decimal, I know this is a lot, is in the normal number. Okay, so first we inserted a decimal. There it is, step 1. Multiply that decimal by 10 to whatever power, whereas that power is how many spaces away the decimal is within the normal number. We chose 8 because here's where the fake decimal was placed, the little yellow. I made it yellow so you could see it. And the real decimal in the number 120 million is actually 8 spaces to the right in real life. Okay, in this example, it was 10 to the 8th because real decimal in the real number lives 8 spaces right. Let's do another one. Here's another example. It's not in your book anywhere. 1,065,000,000. Now this one was rather easy. You inserted your decimal here because 1.2 is the only significant component that was required here. But in this case, that 5 is the last, what we call significant digit in this process, because you're going to need to have that that 6.5 as part of the little decimal thing. So inserting a decimal, 1.065. 1.065. I stuck it right here, and I'm not writing anything beyond that. Only write what you have to. Times 10 to the how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Because the real decimal lives 9 spaces to the right. And if you don't believe me, here it is in my calculator. I don't know if my calculator will show it. I think it will. And if I multiply 1.065 times 10 to the 9th, I'll get 1 million, or that big long number right there. Okay? 1,065,000,000. That's how you can tell if this number indeed equals the normal standard form number. This is scientific notation, this is standard. This is scientific notation, this is standard. Now, notice that we moved the decimal to the right to get it back to its original position. It's a little bit different when it's a little teeny weeny number. Like as in the thickness of the retina. Stay with me, folks. The retina itself is 0.0012 of a meter thick. Stay with me, please. We're going to follow the same steps. Placing a decimal to create a number that looks like it's between 1 and 10. 1.2 look good? I think so. Now, if I multiply it by 10 to the 4th power, I am going to create something that is not what I want. 1.2 times 10 to the 4th. 1.2 times 10 to the 4th gets me that. This is not equal to that. The decimal doesn't live 4 spaces to the right. It lives originally 4 spaces to the left. So instead of to the positive 4, you need to move it 1, 2, 3, 4 to the negative 4. That moves it from scientific notation position left back to original position. So step 2, the other one, this is kind of an addendum to that. If to return the decimal to normal is left, then your exponent is negative. Okay? Here's another practice item. 602, whatever. Where am I going to put the decimal? Where do you think I could put it? Got a couple of you that are cracking on. Very good. Ben. Right after the 6. 6.02 times 10 to the positive, which means that way, or negative, which means that way. negative. Negative 1, 2, 3, 4, 5. So if to return the decimal it needs to go leftward, which in that case it did, then that means your exponent is negative. Now in the second part of our lesson today, what you're going to learn about is what if I give you scientific notation and want you to turn it to standard. We just did standard and made them scientific. What if I wanted you to do scientific and take it to standard? Take, for example, we're in example 2 here. 1.85 times 10 to the 6th. To return it to normal, am I going to move it right or left? Emma? Good. So here's how I do these. 185, that's where my decimal is. Right? There it is. And I'm going to go right 6 spaces. 1, 2, 3, 4, 5, 6. Boom, 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 boom. Inserting commas wherever necessary. My answer is 1,850,000. Let's see if I'm right. 1.85 times 10 exponent 6. 185 and 4 zeros. How about if you had a little dinky number, like this one? 3.29 times 10 to the negative 4. Which way is my decimal going to go, right or left? Right or left? Noah? Yep. 329, there's my decimal. It's going to go left 4 spaces. 1, 2, 3, 4, 0, 0, 0. Put in your decimal. Notice I didn't put in the decimal after 1,850,000. That's because you don't normally put in a decimal there unless you need it. But obviously here we needed it to indicate that the number is a teeny weeny minuscule number. If I left this out, then you would think the number is just 329 with stupid zeros put in front of it. That is required. Okay? Last thing I have for you today before we practice a little bit more, last couple of things, is what if you are asked to order scientific notated numbers? Biggest to littlest. If you're asked to put them in order, here's how I recommend you do it. Solve what each one is, and then just put their natural numbers in order. Okay, 9,900. Do we even have to mess with 9,900? It's already a normal number, isn't it, Dylan? Right. 9.5 times 10 to the 4th. What is 9.5 times 10 to the 4th in normal number land? Emma, what is 9.5 times 10 to the 4th in normal number land? Yep. Here's where the decimal is. Here it is after we've moved it 4 spaces right. What's 9.8 times 10 to the 3rd in normal number land, Grace? Yep, 9,800. We don't have to do anything with 9,900. Which one is smallest? Duh. I know. So small, medium, large, right? So to order these numbers, first place them into standard form. Take scientific, make it standard. Now I'm going to tell you right up front, some of you already knew without even doing this, and I recognize that. I'm not going to go into the whys. You already know why if you got it. Smallest, middle, biggest. Last thing, this is sort of similar to example 4. Go ahead and look at it with me really quick. It's kind of a cool example. Yes, ma'am.
I have a question.
Go ahead.
On these questions, we write the original one or the standard?
I don't care. Oh, you mean if it just says order them from least to greatest?
Yeah. Does it say that or no?
You know what? You don't even get that far today. You actually don't even get that far, so don't worry about it. Okay, example 4. Do you guys see that little thimble? You guys know, if any of you have ever seen sewing, there's a thimble is a tiny little piece of metal that you put over one of your fingers so you don't stab yourself. Okay? And most of you probably know the size of a thimble isn't very big. It fits over a thumb or a pointer finger. There is a teeny weeny plant called the Wolffia plant, which is the size of a pin, like the tip of a pin. And this thimble is filled with these plants. Yeah, kind of cool, huh? Now, just for sake of argument right now, each plant has a mass. Yeah, don't touch it. And you're not, that's why I have you guys pulled away from the wall. And I keep pulling you guys away from the wall. Anyway, each plant has a mass, I gotta do this real quick, of 1.5 times 10 to the negative 4th gram. Okay? By the way, what is 1.5 times 10 to the negative 4th in grams? It's pretty small. 1, 2, 3, 4. 1,500 thousandths of a gram is what each plant weighs. And by the way, in that thimble, approximately a count of 5 times 10 to the 3rd plants, which is 5 times 10 to the 3rd. 1, 2, 3. 5,000 plants can fit in that thing. So I have a normal number and I have a normal number that I derived from the scientific number and the scientific number. If I wanted to find out the weight of a thimbleful of plants, I would multiply how many plants there are in the thimble, which is this, times the weight of each plant, which is that. Most of you would easily be able to do it with standard numbers. You would take 5,000 and multiply it by 0.00015, and in your calculator, if you did that, you would end up with 0.75 hundredths of a gram. Okay? If you did it in standard form. But rather than converting it to standard form, what you need to know how to do, and you absolutely must know how to do it, is use the data that you received in scientific form and simply multiply those numbers. Each plant times how many there are. And this is scientific. Well, how do you do that? I don't know if you guys remember this or not. Maybe you do. But you can commute numbers in multiplication. This literally means this times this times this times this. All of that is multiplied. You can move all of these numbers around so that they're easier to multiply. Take, for example, your normal numbers first, 1.5 times 5. And multiply that by 10 to the negative 4th times 10 to the 3rd. I just commuted using the commutative property, so that now I have my normal numbers side by side. 1.5 times 5, 7.5. And you guys just learned, when you're multiplying numbers with the same base, what do you do with your exponents? Add them. So 7.5 is the result of this. The product of this and this is 10 to the what? Negative 1. So this times this in grams is the same as that. How do I know that? Because if I move this left one position, like it says to, move it left one position, I come up with the standard number. Okay, so when you're being told to take a weird weight, something like this, multiply it by another weird number, so two scientific numbers, first rearrange the multiplication problem so that your normal numbers get multiplied and your powers with the same base get multiplied, and the result is the normal number times the power. That is your scientific notation answer.